Hello, dear children. Study of sound, numericals. Let's revise the important formulae we have studied in this chapter. Velocity of sound is equal to frequency into wavelength. Velocity is equal to distance upon time. Please note, frequency is denoted by the letter nu and wavelength is denoted by the letter lambda. Let's do the numericals. Number 1. Ultrasonic waves are transmitted downwards into the sea with the help of a sonar. The reflected sound is received after 4 seconds. What is the depth of the sea at that place? Velocity of sound in sea water is 1550 meter per second. So here we can see the ship with the transmitter and the receiver. The transmitter produces ultrasonic sound waves which travel through water, strike the bottom of the sea, and get reflected. The reflected waves are received by the receiver in the ship. The receiver converts the ultrasonic sound into electrical signals, and these signals are properly interpreted. The time difference between the transmission and the reception is used to calculate the depth of the sea. Let's begin the sum. Given velocity of sound in sea water is 1550 meters per second. Time for echo to be heard is 4 seconds. You know, the reflected sound is heard after 4 seconds. So try to understand the transmitter produces a sound and it reaches the bottom of the sea and then it gets reflected. So the actual time taken to strike the bottom is half of this 4 seconds to find the depth of the sea. Let's begin. Time for the echo to be heard is 4 seconds. So the time taken by sound waves to reach the bottom of the sea is 4 upon 2, that's equal to 2 seconds. Velocity is equal to distance upon time. So distance is equal to velocity into time. Depth of the sea means it is a distance we have to calculate. Let's substitute the values. Distance is equal to 1550 into 2, and that's equal to 3100 meters. Therefore, the depth of the sea at that place is 3100 meters. Let's do the next question. Neeta heard the sound of lightning after 4 seconds of seeing it. What was the distance of the lightning from her? The velocity of sound in air is 340 meter per second. When lightning strikes, a bright flash of light is generated. We see the flash immediately. The intense heat of the lightning generates a sound called thunder, which is transmitted through the air at the velocity of sound. Let's begin the sum. Velocity of sound in air is 340 meter per second. Time is 4 seconds to find the distance of the lightning from Neeta. So solution, you know the formula, velocity is equal to distance upon time. So distance is equal to velocity into time. Let's substitute the values. 340 into 4, and that's equal to 1360 meters. Therefore, distance of the lightning from Neeta is equal to 1360 meters. Question number 3. How long will it take for a sound wave of 25 centimeters wavelength and 1.5 kilohertz frequency to travel a distance of 1.5 kilometers? Given wavelength lambda is equal to 25 centimeters. The centimeter should be converted into meters, that is MKS system. So 25, we will divide it by 100 so that it's in meters. 25 upon 100, and that's equal to 0.25 meters. Next, frequency is 1.5 kilohertz. Now, kilohertz is not the unit in MKS system. Hertz is the unit. So, 1.5 should be multiplied by 1000. That's hertz. Now, travel a distance of 1.5 kilometers. So, distance is equal to 1.5 kilometers. Again, kilometer is not the unit in the MK system. It's meters. So, we will multiply it by 1000. So, now to find the time t. Okay. So, now you know the formula. Solution. Velocity is equal to distance upon time, which means time is equal to distance upon velocity. So here you know the distance, but you don't know the velocity. So first let us calculate the velocity using the formula. Velocity is equal to frequency into wavelength. So velocity is equal to 1.5 into 1000 multiplied by 0.25. So that we'll get V equal to 375 meter per second. The unit of velocity is meter per second. Now we can use this formula. Time is equal to distance upon velocity. We'll substitute the value of distance is 1.5 multiplied by 1000 divided by 375. So let's remove this decimal point from the numerator. You know the rule. We will multiply the denominator by 10 so that the decimal point in the numerator can be removed. So that will be 15 multiplied by 1000 upon 375 into 10. So let's reduce this. So you know we'll cancel the zeros of the last digits. Yes. Now 15 and 375 are divisible by 15. So let's reduce it. 15 ones are 15, 15 into 25. Now this 25 and 100 can be reduced. So 25 ones are 25 and 25 fours are 100. So we get t is equal to 4 seconds. Therefore, the time taken, the sound wave takes 4 seconds to travel the distance of 1.5 kilometers. Thank you.